how we use the nth term of a linear sequence. Now, that might sound very complicated, but it's actually not bad at all. Let's look at an example. If you're given this information, that the nth term of a sequence is equal to 3n minus 4, then you can start working out different values in the sequence. But it's quite helpful, instead of writing it like that, it's quite helpful to write it like this instead. Just to emphasize that the n in both positions means exactly the same thing. So whatever number I put in for n, I've got to put it into both positions. So, for instance, suppose I use n equals 1. Well, in that case, the first term is worked out by doing 3 times 1 take 4. You remember BIDMAS, you know how to work with negatives, and we discover that the first term of the sequence is minus 1. Next, we can work out the second term of the sequence. The second term will equal 3 times n, which we're taking as 2, minus 4. So 6 minus 4, which is 2. We'll do one more just at the moment. This time I'm not going to bother with the red. You should be getting the idea. The third term equals 3 times n, which is also 3, minus 4. So 9 minus 4 makes 5. So this sequence looks like this. Minus 1, 2, 5, and we can keep going. Could even perhaps do it in our heads. The fourth term is going to be 3 times 4, take away 4, and so that would be 8. But the really nice thing about this way of describing a sequence is that we don't have to start at the first one and work our way up. We could, if we wished, work out any term, any position in the sequence that we like. The 50th term is going to be 3 times 50, take away 4. So 150 take away 4. The 50th term is definitely 146. There's no need to work out the 5th term, 6th term, 7th term, and keep working our way up to get the 50th term. We can jump into the sequence at any position that we like. So that is how to use the nth term in the most basic way. There is another interesting type of question that you can ask, and it goes something like this. If a sequence has nth term equals, let's choose something else, 5n plus 7, is, let's pick a random number, 317 in the sequence. Let's just start with what we know about the sequence. The nth term equals 5n plus 7. Now, if 317 is in the sequence, then there will be some number n that makes that happen. Perhaps it's out there at n equals 20, perhaps. In which case 5 times 20 plus 7 would make 317, except of course it doesn't. So 317 isn't at the 20th position. But what we can do is we can presume that 317 is in the sequence. It's at some position. And then we can try to find out what position it would be at. And we start solving this equation. Take 7 off each side, so that 310 equals 5n. Divide that by 5. Divide that by 5. And that gives me what? 62. Now that's a very interesting answer. N equals 62. It's claiming that the 62nd term of this sequence is 317. And so 317 is in the sequence because we've got a whole number position. If that had come out at, let's say, 62.5, then we would be in between positions in the sequence, in between terms. So 317 is in the sequence. And again, we know that simply because n is a whole number.